Hello and welcome to Ruby Rogues, the best Ruby podcast in the world. Here today on the Ruby Rogues podcast, we have John Epperson.
Hey everybody.
Darren Bremer.
Greetings and salutations.
And our special guest today, all the way from the Netherlands, is Wander Hillen, a software developer and Ruby blogger who has written a great post about the Ruby Free Fiber scheduler interface. So we're going to be diving deep into the internals of the MRI and find out all the exciting things that the new Ruby scheduler can do.
Did you work your tail off to get that senior developer gig just to realize that senior dev doesn't actually mean dream job? I've been there too. My first senior developer job was at a place where all of our triumphs were the bosses and all the failures were ours. The second one was a great place to continue to learn and grow, only for it to go under due to poor management. And now I get job offers from great places to work all the time. Not only that, but the last job interview I actually sat in was a discussion about how much my podcast had helped the people interviewing me. If you're looking for a way to get into your dream job, then join our Dev Heroes Accelerator. Not only will we help you get the kind of exposure that makes you attractive to your dream employer, but you'll be able to ask them for top dollar as well. Check it out at devheroesaccelerator.com.
Now, Wander, I don't think a lot of people know what a Ruby scheduler is because it's not something you do in Rails. At no point in Rails do you have to mess with the scheduler, do you? So we're kind of getting into niche hidden parts of Ruby. Is that correct?
Well, yes, you're entirely correct. And in fact, like the Fiber scheduler is both new and not in Rails. So right now it is niche, and it is something that most Ruby developers will not have to actively deal with. But I think that's going to change in the hopefully not too near future. And that's what we're here to talk about.
I think you're right. And the reason I think you're right and people will care is because it has a direct impact on the asynchronous tasks. And as we all know, the CPUs are not getting any faster. If anything, the CPUs are getting slower or moving to ARM cores, but they are getting more parallel. So making your Rails a bit more asynchronous can vastly increase your performance and hardware efficiency.
Yeah, that's right. Like one of the things that a lot of people don't actively think about, in my experience, when I talk about these things, is like you have during the handling of for example, in just Rails, like if you have a web request, like so much of that is just your CPU just sitting around and waiting and actively doing nothing. Like first you have a connection coming in, but then you have a little bit of activity at the start. You have to route it, but then you have to wait for the rest of the requests to come in. And at the speed that modern computers can work, the network interface is really, really slow. So it's like, get me the homepage or post to this form. And by the time all that this data has finally trickled in off the network connection, Rails could have been doing a lot of interesting other things. And but these days, usually it doesn't. It just sits there waiting for this very slow request to come in. And then it goes off to the database. It's just more waiting. And then when it finally has the results, it needs to send it out. There's even more waiting. And so so much of what your computer is doing is just waiting. And that's waste. That's stuff that it could be doing something else.
I just want to make one real quick clarification. So speak for yourself, because my Rails server, when it's sitting around waiting, is mining Bitcoin. So I just wanted to throw that out there. So it's not completely wasted.
Yes, but does your Bitcoin miner run in Ruby?
No, I'm just being a little bit facetious with you. Yeah, I think one of the things that I wanted to dive into a little bit, and Luke got into this kind of already, is that in my experience, and I've been doing programming for quite a while, getting any kind of threaded programming correct, and having it really be robust is really, really hard. It's really challenging to get right. And that's no offense to anyone in this group or in the audience, right? It's just myself included, a very difficult thing to do. So yeah, I am very interested to kind of dive into more how you see kind of the everyday Rubyist using this capability. And like you mentioned, using the schedule, you'd like to see that change. How can we make that more accessible to the everyday Rubyist. Right now, a lot of these things are taken care of for you by frameworks and libraries. But what's your view on that?
Well, yeah, I like you say, and I agree completely. Concurrent programming is like tricky. It's really like most of it. It's 99% of it is just straightforward, and then just when you're sort of relaxing and think, now it works, then it suddenly doesn't, and you don't know why, and everything sort of just blows up. And I think one of the best parts about Ruby and about Rails is that it sort of takes a lot of things that used to be, pretty tricky, like authentication or good database access. That there are a ton of high quality libraries that sort of take this trouble away from you and just do it. There's a lot of engineering that goes into it, but once it's correct, and it sort of stays correct. I think that's one of the best parts about the Ruby ecosystem. And what you've seen in the concurrency scene, especially about Ruby, like when Ruby was first created, I think, concurrency wasn't as much a thing as it was now. It was like the 1990s. Computers were still doubling in speed every few years. If you had a dual core, that was like, the most impressive computer you'd ever seen. And, so concurrency wasn't really as much a thing as it is these days. One of the things that I think Lucas already mentioned is like you have concurrency and parallelism is way more a thing these days. And people have been struggling to sort of get a good grip on it. In particular, like you could see that with, for example, Node.js, which said, well, one core is all you need. Computers are fast, but doing things concurrent, callbacks is like all you need. And then eventually they figured out callbacks is not ideal. You in a little bit more off the beaten path. You had the Haskell people and the Erlang people that had their own like green threading that would automatically be managed by the language runtime, but it's also not ideal and tricky to get right. You sort of have to make a lot of accommodations in your language to sort of make it work seamlessly. Then Golang came along, which did a lot of things right, and you can really see a lot of other language runtimes that say like, this is a really good idea, we want that too. And I think that's really where the fiber scheduler comes from, because it will take the fibers that have been in Ruby for quite a long time, since Ruby 2.0, and then says, we want to use this way more. This is a super powerful concept, but it's just too difficult to use. What the scheduler is all about is that it will take a lot of complexity out of your hand and put that inside a dedicated piece of high tech that will just do the difficult stuff, so that you can focus on what you really care about.
So we've talked a few times about we've talked about reactors, we've talked about like the potential of fibers, and like there's a few things that are trying to take advantage of it. I think it's Falcon I think the big one that I know about, the new web server or whatever. But like until everybody implements fibers in all their libraries, like you're just not going to get the benefit as like a regular user, right? Like, but there's like promise, right? So we've talked a few times about this stuff, and I feel like one of the difficult things is saying, okay, this is really, really cool. Like, I love talking about this stuff, but like, how does this affect me? And I think that's kind of the question that Darren was like trying to ask. And I think that you, in your article, like you mentioned like a couple of things that I found interesting in this regard. So like one of the things that I find interesting is, so you talk a lot about non-blocking IO, and I wanted to ask you a little bit about this, which is where I'm going. Most of my interactions with non-blocking IO is using or trying to use like, what is it, like poppin or popen 3 or whatever, and you're just like, you run it in testing, everything's like super great, you open files, close files or whatever, and then you go to production and like boom, stuff is like broken, and you like dig in and you're just like, oh well, there's like some, I don't know, there's like, it's something to do with like there's blocking when there's not supposed to be blocking or whatever, and there's nothing they can do about it, like blah blah, and you're just like, dang it. Like anyway, that's my life experience, is mostly reading about it on threads, and I'm just like, just like abandon it.
No,
go ahead.
You shouldn't abandon it. Like I've run into those problems like many times, of course. And like I think like the real problem was like a little bit earlier on what you said, is that you have some things that are blocking and some that are non-blocking. And there's this whole, like there was an extremely famous article about, red functions and green functions, how they can never mix. And yeah, that was really the problem. Like everyone has to sort of switch to fibers first before they can really, reap the benefits. And that is one of the key improvements in Ruby 3.0, I think, is that a few people they went through the whole code base and if you look at all these functions where the I/O actually happens, there's not that many, because even writing a web response or reading from database or whatever, it in the end in MRI it is basically all just reading and writing to I/O objects. So if you can insert good hooks into IO.read, IO.write, kernel.sleep, and there's a few more, then you basically have every use case covered, because every language that does IO eventually, maybe 20 layers down the call stack, but they eventually call read or write, and that's all that happens. So if you add your hooks in there, you cover every library. The coolest part, I think, about the fiber schedulers and these hooks that they make use of is that you get them for free. They have already been implemented, and they should work for every library out there. And in practice, because I know someone is going to ask about this, and no, it doesn't work with Rails yet, but that's definitely something that people are interested in, of course.
Good catch on that. So, all right. So talking about this, my understanding from what you wrote is that really at the end of the day, the quick summary of what my problem really is underneath is it's I'm writing basically a single threaded program that is delegating to a thing that's trying to handle that's doing some asynchronous stuff, right? Because I'm basically opening a stream or whatever, and it's not correctly handling all of the events that are being caused by the system call or whatever. It's been a little while, and I'm totally pulling this off the top of my head, so my apologies for my vagaries here. But my understanding, based off of reading your article, is one of the benefits of fibers is that wrapping things like this is just straight up better, to put it succinctly. Yes, I guess what I'm trying to say is, sorry, I'll try and rephrase my question. Hopefully that'll be better.
Okay.
Yeah, so basically it kind of sounds from what you're saying, wrapping all the reading and the writing, the asynchronous threads that are going on in dealing with streams and things like that, wrapping all that stuff in fiber constructs is theoretically going to give me better behavior. Yes.
That is how it should work. And the reason it does that is that whenever the runtime detects that you're going to be doing nothing for a while, then it says do I have any other work that I could be doing? And if that's the case, then it will start doing that work instead. Just swap back to your original thread of execution, or fiber of execution in this context, when that one can be run again. So instead of a lot of threads that have to be managed by the operating system, and that will take a lot of resources, memory, CPU all by itself, you can now have the Ruby runtime manage these things, and that will theoretically give you a better result, because the Ruby runtime knows a lot more about your program than the operating system, because the operating system has to be super general. It doesn't know anything about Ruby. It needs to be able to run any program in any language, and because Ruby is Ruby, it knows all about Ruby objects and about Ruby operations. So it can be way more specialized and way more effective in sort of scheduling and determining what is the most effective thing to do right now, if that makes any sense. So
I think so.
Because it's not as far away from the program as the operating system sort of has to be, it can be more dedicated and more specialized.
So I'm excited for the fiber version of PO3 then.
Darren.
No, that's okay. Let me give you my mental model of this, and then you can tell me if it's correct or not. So when I think about, let's compare it to virtual machines, VMs. That's a fairly, well, not heavyweight resource, but we're used to that as compute capacity. And now we've kind of grown more into containers, which are essentially just an operating system process. So it's an order of magnitude more lightweight and faster to start up. And you can have many more of them running more efficiently. Now I compare that to threads, which are, again, so now we're going a little bit level down, but I think the analogy still holds, is that a thread is using an operating system resource, but now we're talking about a fiber, which is even more lightweight than that, right? Because it doesn't actually, strictly speaking, use the operating system level resource. It's simply managed by Ruby, like you said. So we can have many more of them. They can be more efficient in terms of the Ruby context and the Ruby language runtime. And so that is, I think, where we were using the technical term earlier, that it gives us more goodness, or it's better. Is that a accurate or even close to good mental model of the difference when we talk about why fibers are beneficial?
Yeah, I really like that comparison. I think you put that really well into words. Basically, you just get more for less, or rather the same amount of throughput for less machine resources in however you want to measure that. So overall efficiency will rise. And there are a couple of things, of course, that where the analogy breaks down. You can run basically any program in a container that will also run in a VM. And in practice, fibers, as they are implemented in Ruby 3.0, they still have some of the things that Ruby in general will have to deal with. So, for example, if you have, as a very poor comparison, but Ruby garbage collection is stop the world. So if it starts collecting things, then your program won't run. And if you go up a level from your comparison, like if you would run your program in multiple processes even, then you could have still throughput while one of them is garbage collecting. And that's something where already, if you're using threads, then garbage collection stops the world for a few hundred milliseconds, depending on how big your memory is. And so you have the closer you get, the biggest upside is also the biggest downside. So.
Yeah, I don't think anybody's saying fibers are a panacea. They don't cure all of the problems that we might have, but some of the issues you described, garbage collection, things like that, I think regardless of where your code's running, you can always run into those items and be impacted. I guess, and it's not a perfect analogy, but like all other things being equal, though, that sounds to me like some of the main benefits that you get.
Yeah, for sure. They are just a lighter weight alternative to threads that is 99% escapable for 10% of the cost.
Right. So, and because a lot of the frameworks like Rails or other libraries that we use are doing some of this heavy lifting for us, they're doing the thread management or the handling of parallel requests, then I guess that kind of brings us back to that question. Are we kind of, as kind of your average Rubyist or developer, are we kind of subject to waiting for some of these frameworks and libraries to adopt the use of fibers, or are there other things that we should look at in the meantime?
Well, I think you can already run a large percentage of websites on the Falcon web server, which uses fibers very heavily. I happen to know that, for example, even in Rails, like you say, the reason the fiber scheduler doesn't operate well with Rails at the moment is because Rails is pretty heavy local state for threads. So that's a downside where, because multiple fibers live in one Ruby thread, they will sort of think they're in the same Rails request, basically. And then all your requests start bleeding into each other, and there's just tears everywhere. It's terrible. So that is one thing that doesn't quite work. But you see, like the Rails people, they are not stupid, and they see that the same amount of benefits for less resources. That's something we want. And asynchronous operation and more concurrency is also something they want. So slowly but surely they are working towards making this possible, and it's something they've done before, because back in the day, like maybe some of the older people know that there was this huge push to make Rails multi-threadable, because before that it was everything in a single process, and oh no, I can't run Rails in Puma, and everything will blow up. And yeah, now it's just a sort of next cycle in the evolution. Actually, now that I think about it, sorry, but there's I think Rails 6.1 or 6.2, I saw a really cool feature coming by that was basically something for active record, where they say like you can do like my model dot where some condition dot load async, and this load async would then sort of do your database request in somewhere off to the side in a dedicated thread pool for these things. And the advised usage of this feature was that you could do like one database request, and the first you do load async, and the second one you just do straight up. And they would sort of run in parallel and then come back at around the same time. And so if you have a controller that does two very separate queries, then you can just do these in parallel and gain some time. I think that sort of thread pool off to the side that does stuff, IO intensive stuff that's mostly waiting. This is just the dream use case for fibers, right? So that is a place in Rails that would benefit a ton, I think, from fibers. So I'm not in the Rails core team, but I can't imagine that they haven't thought of this themselves.
Yeah, that's so one of the things that always strikes me about these conversations, right, is that you talk about the benefits of threading, and then you suddenly realize that like, oh, well, the API for using this kind of sucks. I feel like and that's like, that always feels like that's like the big hang up, right? Is like, well, it's not easy to use. I just want to write stuff, like, because we think about everything as a sequence of events, like, and so we write our code like a sequence of events, and that's how almost all of our APIs are written. And I always feel like the big struggle is sort of like, I don't know, even when you're talking to somebody about threading, right? Like we're thinking about, okay, well, now I just have two threads that are running a sequence of events, right? Like, and so everybody's just thinking about it that way, and all of our APIs are written that way. And I was just thinking about, as you were talking about the async thing, right? Like I literally am going to have to say, okay, do this one on the side. I'm going to run this one in line, and then I'll like sync them back up together, right? Like I'm having to manage all of that as opposed to just being able to like, all right, I just want to run these 10 things and I want them to all get run in parallel. Like, I mean, you can do that. I mean, we already have threading stuff to do that or whatever, but like
there are definitely some use cases
reach for that very often.
There are definitely some use cases that kind of easily fit into this pattern, right? And I think you just mentioned one, which is a scatter gather. I need to do a number of different queries, and I'm just retrieving just like independent data, and I'm going to put them all together and return a result. That's pretty easy to reason about. But yeah, John, I agree with you. Like in a lot of the use cases where we're developing, it's much harder to reason and think through our problems that way that we're solving. It's much easier to think of them in a linear fashion. And so I think given the right use cases to apply this, it's great. Then there's going to be others where it's going to be a lot more challenging to do that. How do we practically make that accessible and actually in the end make the whole thing faster, make our service faster, and also maintainable as well?
And you're going to have to get rid of all those thread.current.user calls that you made. Let's be honest. That's going to be a problem with all the fibers running around.
Mm-hmm. Yeah, I was actually talking with, if we're talking about like real life use cases, I was talking with someone at the local Ruby meetup, and one of the, like, they made the very sort of pointed observation that their background workers, like whether it's Sidekick or Skewer or whatever, they're not actually working that much. Like some of them are, don't get me wrong, but a lot of them, like, at the company I currently work for, we have an entire cluster, and like 99% of what it does is API calls and sending out mails, and that's fine, right? Like that, if I would have to guess, I think the majority of Rails background workers are actually just like API and mail waiters, and they just wait. That is another thing that I think is a really good use case for fibers, because why have Sidekick with like 5 or 10 or maybe even 20 threads, and all of these threads are just waiting for your mail API to come back with like, I definitely sent your mail. If you do that with a fiber-based worker, 20 concurrent fibers is absolutely nothing. I've run tests with like 10,000 fibers concurrently on the machine, and it doesn't even sweat. It doesn't even get above like the memory use of Spotify or something. Okay, that's a bad example. It's an Electron app, but
I mean,
You know,
you make a good point that, and I think that is another category of use case that fits into this well, which I would kind of describe as service or microservice orchestration, where I need to do a task and that involves me calling out to a number of other services. You know, I'm sitting there waiting request for response, and that sounds to me like a perfect use case for fibers. I could run many of those within a Ruby process and without any trouble. And that's going to be more common, right? As more and more people move to service-oriented architectures, that will be more likely come up more often.
I definitely, so Microverm's always been like on the forefront, right, of like threading technology and being like, oh, this gives me a benefit. Let me just add this into Sidekick or whatever, right? Like, so I definitely am just kind of like, all right, well, he'll just show up one day with a new version of Sidekick that does fibering. It'll be fine. Or rastering or whatever he thinks. Like he'll write a blog article and be really sweet. And he's going to just tell us, this is what I think is going to work best for Sidekick. At least that's what he's always done in the past, I feel like. So
yeah, you want it to be easy to do the right thing. And if the right thing is I just upgrade my version of Sidekick, that's the best way to do it.
I mean, I don't mean that. I have a lot of respect for Mike Worm, right? And I've always felt like in the past he's just been at the forefront. So, and it's just been awesome. So I just assumed that once he had the time and he'd figure out what seemed the best way to go.
No doubt.
And if he does it, someone will compete against him because that'll happen. But
yeah, it's true. Although I do have to say that it is kind of tricky because, you know, I can see why some of these things are like, especially when you have really CPU heavy tasks, and they don't come up too often in like Rails-based applications, but every once in a while you have just this one endpoint that does a ton of work and, you know, maxes out the CPU. And that is like, as of yet, just not a real good case, not a good use case for fibers because they are cooperative multitasking. If one thread of one fiber is not behaving well, then it can just sort of hog all the time and never give back its thread of execution. But that is something I think before we will just see a real wide-scale adoption of fibers, that it's something that will be or will need to be tackled.
Are you under increasing pressure to ship code faster than ever before? Then it's time to work smarter with Raygun's modern approach to error and performance monitoring. Raygun gives you instant visibility into the health of your software, and what makes it so unique is that it not only tells you when something's gone wrong, it shows you exactly where it's gone wrong and how to fix it, right down to the line of code. Made by developers for developers, Raygun has built a suite of monitoring tools that are used and loved by thousands of software teams every day. Monitor every corner of your tech stack with widespread language support and native integrations with GitHub, Jira, Slack, Bitbucket, Octopus Deploy, and more for even greater visibility. Visit Raygun.com to resolve issues faster and deliver flawless digital experiences for your users. That's Raygun.com to get started on your free 14-day trial with plans starting from as little as $4 per month.
So that's a good call out. So the starvation problem that you mentioned, where one fiber kind of goes, I was going to say goes off the rails. No pun intended. Where it chews up the CPU. There's no guardrail there essentially to protect the other fibers? Will they eventually just get starved out at this point? Or I'm guessing probably that's the case because there's not an operating system there to protect against that, but I'm not sure.
Just put everything in a timeout. That's the trick. Just use set timeout everywhere and problem solved. Timeout. It's great. It's a great Ruby call. Use timeout in your code today. Mm-hmm. Don't believe the haters. People will talk about not using timeout in Ruby. They're just flat out wrong. I got timeouts everywhere, and my code is always quick.
Quick to crash?
I'd say quick to hit the timeout. Do you set the timeout like really short?
It's a truly exceptional part of a Ruby language.
I'm pretty sure that everyone's like silently fuming at this moment.
No, this is. I mean, Darren, you called this a starvation problem. This sounds to me more like the opposite of a starver. Isn't this a kind of greed problem you're describing, where one fiber goes rogue and kind of eats all the CPU?
Yeah, one fiber's greedy, everyone else starves.
That's right.
Yeah. Well, so. I'm gonna shamelessly plug my own blog here. Actually, the function you want is not set timer, but it's a C function. It's called timer _set time. It's a Linux syscall. So, because Darren mentioned the starvation problem, and he hits the nail right on the head. Like, if you have a fiber that's not behaving, then it will just not give back its slot. All the other fibers in your system will just wait there and never be scheduled. And once again, tears everywhere, people crying. It's not a fun time. So, but what you can do, and this is I was just playing and I'm like, that's really bad. Like, I don't want all my fibers to just sit around and do nothing. Like, what can I do? So at the time, I was also working on a pull request for, shock and awe, Ruby fanatics cover years for another language. That was basically making this exact type of system. So I was like, maybe I can just steal that solution and put it in MRI. So there's basically two types of solutions for this. One of them is what I like to call the Erlang solution, is that they have a concept called reductions. And every, I don't know the exact number, but let's say every 1,000 function call that a fiber makes, the runtime will check if it still has any function calls remaining. And if it doesn't, then it doesn't get continued, but it gets scheduled out. So that's a natural way to limit how long fiber can run. So I tried to make that. It was very easy to make because Ruby is an interpreted language. You can monkey patch everything. It's amazing. So I tried to monkey patch the send function. That didn't work, but there were some MRI internal APIs that I could hook into. But in the end, that wasn't really that great. It worked, and you could have really poorly behaved fibers that would, after their amount of methods was used up, they would get scheduled out, and all the other fibers would be scheduled again. So that worked really well. But it was like 5 times slower than before. So I was like, that's probably not worth it. And then later, I realized that there's also another way of doing things, and this is the way that languages like Golang and that Haskell use this. They ask the operating system, in this amount of milliseconds, it differs a little bit between languages. In this amount of milliseconds, can you please, sort of send me an interrupt so that I know to do stuff? That also works. So you would tell Linux, in my case, in 50 milliseconds, can you give me an interrupt? And then you install an interrupt handler in MRI that will schedule out the current fiber. And that worked surprisingly well. Like, the overhead was super low. It was like 3% slower than the Erlang version. Not the Erlang version, the basic version without any interrupting. I just made a very long computation, ran it without any interrupting and with interrupting, and compared the time. So it was 3% slower, but it didn't have any fiber starvation problems. And I thought that was decent, especially because you can switch it on per fiber. So if you have a fiber that might be bad, then you can turn it on just for that fiber. And all the ones that will be fast, you can just not even pay the 3%.
Where can we get hold of this?
Nowhere yet, because after that I got engaged
vaporware.
Vaporware. There's a very good proof of concept on the. Well, it's not vaporware. You can see the code online. It's on my blog and on the repo on GitHub. It's just not Rails quality production grade.
Yeah, just tell them it's an alpha or a beta release. It's just not. That's all. It's not vaporware.
So this is the preemptive fiber concurrency post, yes?
Yeah, that's the.
So just one thing that I immediately thought about when we first kind of went down this rabbit hole in the first place is, so obviously if the CPU is being tagged the whole time, that can starve other things. But I was kind of thinking about the most common case that we have in Ruby, which is memory usage, right? So I feel like things that use a lot of memory are they typically use more CPU, but they're not necessarily going to completely use up my CPU. Is there a tendency for fibers to be more or less performant with that, or is that kind of unknown, or just by use case? I was kind of thinking. Go ahead.
I hesitate a little bit to say no, it will definitely be better, because whenever I tried something like that in the past, and then someone comes up with the absolute worst case you can imagine, and so I won't say always, but if you have a fiber-based solution for something, then it will usually, and with usually I'm going to bet like at least 90% of the times, it will be better memory-wise than the thread-based solution. Although, as always, careful profiling will save your life.
Yeah, absolutely. I was specifically thinking from the other direction, which would be like, so if I have something that's memory intensive, right?
Mhm.
Like, so I'm sorry, let me rephrase the question again. So the original thing that we were talking about was things that are CPU intensive, right? Or
Yes.
basically CPU blocking pretty much, right? Like those kinds of things tend to perform less well with fibers. And I was kind of thinking things that are like memory blocking, right? Like those kinds of things I feel like they're going to be more CPU intensive generally because you got a lot of stuff going in and out of RAM, therefore lots of CPU usage or whatever, but not necessarily. That might not be CPU blocking at the same time as memory blocking. So
I see what you mean. Yeah. Well, in this case, and it's the most terrible answer. Sorry, but it depends. And here's kind of why. So
perfectly valid.
There is if you have a Ruby thread, is mapped one-to-one an operating system thread, and so it will have all the associated machinery that an operating system thread will have. So it will have thread local state, it will have its own call stack. Whenever you make a new one, a large portion of that call stack is already allocated. Once again, this depends a little bit on your operating system, but all in all, they tend to be fairly heavy on the memory use. Now, a fiber itself is very, very lightweight. It's just a Ruby object with a couple other small things attached. Like it does have its own call stack, but they don't allocate a lot of memory for that up front. It's very lightweight memory. And so here's kind of where the trade-off comes in. If you have a lot of threads that each do a small thing, like most web requests, then the threads will definitely be way heavier, because just the overhead from being a thread compared to the overhead of a fiber, the threads are just so much heavier that will outweigh, and the fibers will win. But if you have a solution where each sort of concurrent unit, whether it be a fiber or a thread, they each sort of allocate a gigabyte, and then they do some sort of really intensive stuff with that, then the overhead of the thread, it's larger than a fiber, but it's not excessive. It's like probably not even a full megabyte, or maybe a few megabytes, again, depending on your operating system. So in that case, allocating a gigabyte for business logic is going to way outweigh whatever you are doing as your concurrency solution. Does that make sense? So if your individual task is really big, then it doesn't. The overhead from fibers or thread doesn't really matter.
Yeah. Okay. Yeah, that's pretty much what I was about to try and summarize it as. Basically, it seems that fibers are a good match for web requests in general, because there's a lot of waiting going on. But if I have like a bunch of requests, like processing PDFs, for example, I feel like that's a pretty common use case. It might not necessarily be as obviously better in that case, but I mean, we're not saying no. I'm just saying that it sounds like maybe it's not clear that fibers are better in such workloads.
In such workloads, it tends to sort of fall off. That is true.
Cool.
Although I do think that, at least in most of the things I've worked on, there's always been a mix of this sort of power law distribution of your requests, that some of them are always quick, and some of them are always slow, and the rest of them is sort of somewhere in between. So if you have a service where everything is heavy, then you're probably not going to see a lot of benefits. But even for things just like health checks, or I don't know, surfing the homepage, stuff like that is, there's always going to be some things that are going to be much quicker than
I'm imagining some wins around slow queries, things like that. That's the one that sticks out to me as like being a good fiber win here. If I have a website that has slow queries like that, well, that one can just like take its time or whatever, but it won't be blocking other things anymore, maybe.
Yeah, for sure. Yeah, slow queries is a really good one. Slow anything as long as someone else is doing it. So slow API calls,
yes,
slow database calls, slow.
I think that's great. I'm happy to get all my requests served, and everyone else can go shove it.
I mean, it almost sounds to me like at this point in time where we understand with this, you want to carefully select the use cases where you apply this pattern, right? Because we've talking about different characteristics of workloads, whether they're CPU intensive or memory intensive. There's a lot of different variables and permutations there where one fiber could impact others. And these are problems that over 40 or 50 years of computing, whatever it's been, that operating systems have figured out how to do pretty well, right? Mm-hmm. Because like you said at the beginning, operating systems are general. They deal with all kinds of scenarios. They're battle tested. And so they have to deal with this sharing of resources. And in fact, that's what I used the analogy earlier of containers. Containers, actually, the analogy does break down because containers use operating system controls to share or protect against the starvation problem, to say this container process is only allowed to use this much resource or can only see these file system resources, whatever the case may be. So in the case of fibers, we don't have, it's still, I guess you could say earlier on in its life cycle, we don't have all of those guardrails. We don't probably have all of the lessons learned over many years of computing and operating systems applied to fiber. So it almost seems to me like at this point, it's a proceed with caution type of pattern, that if you have the slow query, if you have a service orchestration, if you have some of these well understood patterns, then that may be a good fit. And if you have, widely varying characteristics of your workload, like you mentioned, all over the board in terms of slow, fast, in between, lots of CPU, lots of memory, then maybe you want to be a little more cautious or go with the more established technology. That's kind of what it seems like to me at this point.
It would be sweet. I just thought of this as you were talking. And obviously, this is just somebody saying stuff. So please don't take me too seriously. Anybody that actually works on Rails core or something. But I'm imagining it'd be kind of sweet, right? If in my controller, I could just be use fibers on this call, use threads on this other call. That might be kind of cool.
That would be nice.
It basically just kind of going off the fact that good point, right? Certain use cases are going to be better. Some of my endpoints are going to be PDFs, and I'm not really apparently going to want fibers, right? And some of them, there are apps that do a lot of actual work. in those cases, you're not going to want to use fibers, but other things, yeah, probably the general use case sounds
I like that idea.
It might be too late in the call chain to make that happen, but that would be I imagine that's the API I want. Whether it's possible or not, I don't know.
Well, we're just at the requirements phase right now.
Yeah, that's right. Exactly.
We're not implementing this yet.
I'm the PM that everybody hates. That's just it would be really sweet if I could have this.
That's right. It's John, the code freezes tomorrow. Yeah. I know, but it'd be really nice if we had this.
Sorry to everybody that I just gave some sort of trauma to.
I think here too, there's just a lot that we can sort of learn from operating systems and learn from other languages that have just, some of them have really good ideas, and it would just be a shame if we didn't steal it. We're the rogues after all. The Ruby rogues.
No, copying is good.
Yeah, copying is good. If it's a good idea, why wouldn't you use it?
Yeah.
So here there are a lot of things where I think, for example, Golang or Haskell just has ideas that we should definitely sort of. It also has downsides, and I'm not an MRI expert, so maybe there's someone that will pipe in and say this is not going to work because these 5 reasons. I'm yeah, okay. But I do think there's especially if you have things like work stealing, where different threads can take fibers from each other, so that if one of them has a really long running fiber, that the other ones can just say I'm doing nothing, why don't you give me some of your work? That would be a huge benefit and sort of immediately solve basically half the problem.
One of the things I really like about your blog post is the level of detail it goes into. It even includes some of the MRIC code. So you must have gone into this in quite a lot of depth, yes?
Is that the question? Yes.
Yes, yeah. It's one of the things I like about it. So you're not afraid to get into the actual MRI implementation and kind of talk about the under the hood stuff.
I agree.
I've been getting into more with. I've been trying to get mRuby working. I'll talk about that during the picks. but I've been getting into my kind of C Ruby interface, and it really is fascinating to see how it works. It wouldn't be fair to not mention Sam Williams in the context of this episode. You mentioned him yourself in your blog post. Sam Williams, otherwise known as, I think, Code Otaku. I think he's Code Otaku on the Ruby list, or IOquatics.
He has a bunch of things. I think he's both, actually. I've got Otaku and IOquatics, something like that. But yeah, Samuel Williams is the author of the async framework and all the associated gems. So I have async DB, async HTTP, Falcon based on that. There's an async fiber scheduler implementation. It basically all builds on each other. And yeah, he has done a ton of amazing work. Mad props. And yeah, what you mentioned on the C code of the MRI implementation, he has driven a lot of the implementation of the fiber scheduler. You can see on the Ruby bug tracker a lot of the stuff where this is hashed out, and then Matt says like, I like this, but can we do it a little bit more XYZ? And then there's just a lot of debate going forward to make it the best possible. And actually, I would recognize, or not recognize, sorry, not a native English speaker, recommend that everyone has a look at the Ruby code. Just, it's all on GitHub, it's all open source. And yeah, it's way more readable than you might think. And just knowing how it works a little bit under the hood can just make your Ruby experience a lot better, even if in your day job you do nothing but make Rails controllers. It's definitely recommended. In
addition to writing all the async stuff, Sam Williams has also written Falcon, the web server, I believe. That's another one of his projects. And he put a post on Twitter recently where he shows it running at 673,000 requests, not per minute, but per second. 673,000 requests per second, which is not bad, is it? It's not terrible. It's okay. John's shrugging. Darren's mocking that figure, thinking that's but a drop in the ocean of my requests. But 673,000, not bad as far as the request per second goes.
No, I like it. I was trying to translate it to my Bitcoin hashing. Sorry.
Right.
You have no more time for Bitcoin hashing at that rate.
And
he's done a ton of amazing job with Falcon. I think Falcon is also one of the few Ruby web servers, apart from a few other ones that are also fiber based, that do a really good job at WebSockets. So apart from these insane request per second numbers, he also has a picture somewhere where he has tens of thousands of WebSocket connections open on a single process, and you're just like, wow. That's something that you really struggle with Puma or with Unicorn, but that's just something you get out of the box. And WebSockets, a lot of waiting, not a lot of computing. It's also one of the sweet spots for fibers, really.
I certainly would say that I'm very happy for how far Puma has gotten me, but I'm very happy for the day that I get to pick something new. I hope that it's Falcon.
Yeah, and I tend to, these days, I must admit, I tend to block on the database more than the web server. I tend to hit the limits of the database way, way before I start throttling on the rest of the system. Blame that on my own Postgres ineptitude or whatever else is going on. But certainly, I mean, go back about 7 or 8 years, then Rails would usually top out on CPU memory before anything else. I haven't had that problem for a while. I've always blocked on database.
Yes, it's really easy when you buy the RAM machines to not have to worry about memory anymore. But yeah, jokes aside, yeah, I feel like Rails has been a memory hog for most of my career. But yeah,
you've been working with
Rails also just does a lot, right? It's everyone always says Rails gives you everything for free, but it's actually not free. That's where all the memory goes.
Well, yeah, I mean, to be frank, to be frank, the first thing that I do is I say, I wonder like how many parallel requests I can get on this machine. Let me configure Puma and Passenger or whatever it is that I'm using to completely max out my RAM. So it's obviously I'm eating my own dog food here, but yes.
Rails is a conspiracy started to sell memory. It's all a plot. DHH is in bed with big RAM.
Yeah, this is in line with the
RAM, and I cannot lie. Yeah.
This is in line with the management saying that any given task will take the time that is allocated to it. And so this applies to memory as well.
Yes, it is one thing that I definitely feel like it's very important for the person that is sort of making the decision on how big the machine is to be separate from the person that configures said machine. Because, I mean, I don't know. I've been asked like how big of a machine should be allocated. And I'm like, if you give me a bigger machine, I'll use it. Like that's how it works.
That's right.
Cool. Anyone else have any questions? Did you have anything that we haven't gone over yet, Vander, that you feel like we should hit up, like that we just like missed out, that you're just like upset that we ignored?
Well, upset, definitely not. No, we did a pretty good overview of like everything that the Fiber scheduler can sort of bring and will hopefully bring in the future. There's one thing that I'm personally very excited about is that you see a lot of operating systems. They are starting to expose asynchronous system calls as well as right now. The all non-blocking I/O is you try to do something, to read or to write or to whatever, and then operating will say like, whoa, no can do. And then you ask it, can you please tell me when it is possible? And then, you got to sleep. Sometime later, the operating will come back and say, it's possible now. And then you have to try it again. What the hell? This is like 3 system calls for something where you can just tell the operating system, okay, please do this for me and come back when it's done. And this is like a really asynchronous system call. That's something that Linux is really working towards, the IOU ring interface, which is one of the coolest developments in Linux land that I've seen in the past few years. There's a lot of development going on there. And what I really like about the scheduler interface is that it's already sort of anticipating that. So it's already sort of making provisions for like, when this becomes possible, then we want that to have automatic hooks as well. And the other week I saw that Windows is going to have an interface called IO ring. So they just dropped the U, but basically copied the rest of it, which is a great idea because it's a really good interface. And yeah, in this, I hope this spreads and becomes more common in all the languages, because once again, it's just an improvement over the current state of things. You get more for less, and that's what the trend of computing has been all about.
And then one day, Windows will just be an interface that's running on top of Linux anyway, so it'll be fine.
Any day now.
Yeah, I'm still waiting.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
All right, I think we're going to picks, if that's it. Who shall I pick first? My picks. I'm going to pick Darren first. Darren, what are your picks?
Okay, my pick for this week is part pick and a part an area to watch. So up until recently...
That's not allowed, I'm afraid. You can either have a pick or an area to watch.
The alarm bells are going off. Okay, we're going to call it a pick. Up until recently, there were only 16 different ways that you could run a container on AWS. And so the folks over there really felt that they needed a 17th way. And so they launched AWS App Runner. And it's pretty interesting. It's similar to like a Heroku, I think, or other type of technologies where you can take your, we'll say, Rails app or other apps and kind of package it up and easily run in a container on a managed infrastructure. So here's why I say that it's part area to watch. At this point in time, App Runner only supports Node and Python. I'm anxiously looking forward to them adding Ruby support. So lobby your local rep if you talk to them. But this is definitely an area to watch out for. I'm a big fan of containers. I mentioned them earlier. I think Ruby, Rails, and containers go together like peas in a pod. So I think this will be definitely a technology to keep an eye on going forward.
Very nice. John, what are your picks?
So Beanstalk 2.0, is that what we're saying here?
Yeah, pretty much, yeah.
Yeah. Okay, sweet. So it'll also be abandoned about 2 years after they finally get Ruby.
Isn't that what Google does? That's a Google thing, not an Amazon thing.
No, Amazon. I mean, Beanstalk is a great example of Amazon also doing it. So hang on a second, guys. Sorry, I had a pick earlier and then I left the page and I completely forgot what its name was. Okay, so just recently, first of all, I should say that I have over the course of my life enjoyed many things that Blizzard Entertainment has published. They've published a number of games. You might be familiar with StarCraft and Diablo and WoW. That's probably the one that most people can think of. So I'm not talking about any of those games, but there's this YouTube channel that back in the day you might have actually seen this. The Carbot Animations. They make animations about a number of things, but mostly about various Blizzard games, and they're just hilarious. And if you ever played any of the Blizzard games, you should absolutely, if you've never checked it out before, just go watch, because you will just be like, oh, that was totally me. But anyway, I watched them I don't know 4 or 5 years ago, I think, probably on something or other, and then just recently I just happened to see it pop up in my YouTube feed and discover that they have published even more animations. So I just recently had this renaissance where I went through all of them over the course of a couple weeks. It's great. Highly recommend going to watch them. Very entertaining. Totally worth. That's my major pick for today. That's my only pick, actually.
That's very nice. What am I going to pick? I'm going to pick what I picked last time. So last time I was going to some Ruby adventures with mRuby, and I found a very interesting post on a dev blog by a man who was using mRuby to sneak Ruby code into Windows to essentially make what looked like a Windows GUI app, but was actually an mRuby app. And I totally failed to get this to work and appealed for help. And because I never, ever, ever give up on especially pointless tasks, then I fixed it myself. So I'm going to pick my solution to my own problem that I mentioned in a previous pick. Quite simply, you just have to kind of type in some commands and change how things compiled using the Visual Studio compiler, and then everything will start to work, and you can put Ruby into Windows into places it probably shouldn't be. So there we go. That's my pick.
I actually happen to know of an application that is done in mRuby, and I only discovered it because I happened to get an error message one day, and I was like, wow, this is basically a Ruby backtrace. And yeah, anyway, so if you're familiar with the Civ franchise, this is when I bought Civ 6. I don't remember exactly, but it came with a companion game called Sid Meier's Starships. It's apparently done in mRuby. At least a portion of it is.
Is this Sid Meier's Civilization 6?
I think that's what I got it with. I don't remember exactly. It was either 5 or 6, but I think it was 6. And it came with a companion game called Sid Meier's Starships, which is a strategy kind of game or whatever. Well, I guess Civ is also a strategy game, so it makes sense. But yeah, anyway, yeah, mRuby application.
That's very cool.
I'm sure there are others.
Sid Meier's Pirates. That was my favorite Sid Meier's Pirates game.
Nice.
Wander, what are your picks? Do you have picks for us?
Oh, I forgot to make any picks. I can definitely second Carbot Animations, because that's just amazing. I discovered them a few months ago and I just went through them all, because if you've ever played any of these games, it's a very simple animation style, but it's they're very short each, but they're just this has happened to me in game a million times, and I'm damn, he just managed to condense it so well. Yeah, I was planning to do more research into something called Copilot, which is something I discovered lately, and it's a language for Haskell, so Ruby is, but well recommended, and it compiles down to sort of ultra hard real-time C that is guaranteed to run in your main loop in the same number of cycles and the same exact amount of bytes every single time. So if you absolutely must run a starship or a nuclear power plant or something, then this is the library you would use to generate code for that. And what I discovered was that someone wrote the backend for that will create code for your Arduino. So I'm not entirely sure what I'm going to control, but maybe like a barbecue or something. And I want like an absolute bulletproof implementation of my barbecue control code.
That's very nice. And if people want to read more of your work or contact you, where can they go?
I have a blog and a personal website with my information on wjw.eu, where you can find all my writings and musings and contact info.
So your blog for me appears to be wjwh.eu.
I'm so glad you said that, John, because I was afraid to make that correction.
I'm not trying to correct. I could be wrong.
Did I forget my own name? Yeah, no, wjwh.eu.
Okay, cool. Well, maybe you had two domains. I don't know.
I should maybe just for every time I forget. Yeah.
And there's lots of really great articles on there. Also, check out devchat.tv, where Chuck has a lot of new stuff going on. And until next time, I think that's it from us. So thank you very much, Wander, and hope to hear from you again soon.
Yeah, I had a good time, and all the best. I mean, it's evening over here, but I understand some people just had lunch. And have a great day with the rest of your day.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.